Today's lesson is on quadratic properties. So we have 4 objectives today: quadratic formats, quadratic characteristics, converting formats, and 5-point graphing table. All right, so remember that quadratic functions are functions that have a largest exponent of 2. So let's look at some examples. For instance, so those 3 equations have an exponent of 2, the largest exponent of 2. So that, and that. So see, you have x squared. That squared term is always involved in a quadratic function. That's what makes a quadratic function a quadratic, is that 2, that exponent of 2. All right, so quadratic functions have specific characteristics. So the parent function of any quadratic function, remember the parent function is the smallest possible, the simplest form of a function. It can't get any simpler for a quadratic than y equals x squared. This is what, actually, let me show you how to graph y equals x squared. So if we look at y equals x squared, okay, let's just look at that really quick. If we look at, so watch up on the screen, y equals x squared. Okay, if I want to plug in 0 for x, what do I get for y? Well, what's 0 squared? 0 squared is 0, right? So one of my points is 0, 0, and that's what's plotted right there. I'm just graphing the parent function. Okay, so what if I wanted to plug in 1? So what's 1 squared? Well, if I plug in 1 for x, 1 squared is 1. So 1, 1. So let's graph that piece. 1, 1. Okay, what about if I plugged in 2? So if I plugged in 2 for x, what do I get for y? Well, 2 squared is 4. So 2, 4. And then I'm going to mirror it to the other side. My open math kind of does this for you, but on this, if I wanted to do, for example, oops, thought that was an eraser. If I wanted to do negative 1 squared, don't forget when we plug in a negative, we have to put parentheses around it. So negative 1 squared is 1, isn't it? Negative 1 times negative 1. So that's where this piece goes. And then if we plugged in negative 2 for x, negative 2 times negative 2 is positive 4. Okay? So that's that piece. So let's kind of put it all together. We could see that the parent function of a quadratic looks like that. Okay? Now, that's also called a parabola. So a quadratic function, the shape of the graph is a parabola. And the vertex represents the smallest, which is also called the minimum, or the biggest, the maximum point on the graph. So in this case, look at where our vertex is. Our vertex is a minimum point. Our vertex here is a minimum point at 0, 0. If it was going to be a maximum, it would look like this. Okay, that's a terrible looking parabola, but you get the point. That would be a maximum. Okay, this is a minimum. So it depends on which way it opens up or down. If it opens down, there's a maximum, right? There's a highest point. If it opens up, there's a minimum, there's a lowest point. The axis of symmetry. Okay, the axis of symmetry is a vertical line. Remember, a vertical line looks like this. Right? That's a vertical line. So it's a vertical line of symmetry of the graph. A vertical line of symmetry of the graph. So where would it be on this graph? Oh, well, let's look at a note. The axis of symmetry always passes through the vertex. So look at our vertex, look at the graph. Look where I'm going to draw the axis of symmetry. So it's right in the middle. That axis of symmetry divides the graph perfectly in half, right? It's equal on both sides. So you can fold that parabola over and it would match, the parabola on the right side would match the parabola on the left side if you folded it over on the axis of symmetry. Okay, it divides the line in half, the graph in half. Okay, now don't forget the axis of symmetry is an x equals. So notice right here, right there, it says that the axis of symmetry is always x equals something. In this case, our axis of symmetry is x equals 0. It's always going to be the x part of the vertex. So if your vertex is 0, 0, your axis of symmetry is x equals 0. If your vertex was negative 1, 5, your axis of symmetry is x equals negative 1. If your vertex was 3, 7, your axis of symmetry would be x equals 3. Do you see the pattern? So it's always the x point of your vertex. It's always that x equals whatever the x point of the vertex is. Okay, whatever the x coordinate of the vertex is. Okay. So let's talk about transformations. Now you should recognize this is the parent function, that y equals x squared. And this is all the transformations that can happen. So let's talk about it. Let's review it one more time. If a is greater than 1, the absolute value of a, it's a vertical stretch. If the absolute value of a is less than 1, it's a compression. If a is negative, it's an x-axis reflection. All that means is instead of opening up, it's going to open down. That's what an x-axis reflection means. Okay? That's what an x-axis reflection means. All right. H, if it's x minus h squared, it's a right shift. If it's x plus h squared, it's a left shift. And then k, if it's a positive, it's up shift. If it's a negative, it's a down shift. Okay? You already know this is all review. That part was review. H and k should be review. All right, so let's describe the transformations. So we're going to take a look at this first example, y equals x squared. And how does it transform? What are the different transformations it takes on from y equals x squared to this guy, y equals 3 times the quantity of x minus 1 squared plus 4? What is the difference? What's happening from the parent function x squared to this transformed function? Well, the first thing is that 3, isn't it? A equals 3 in this case. If A equals 3, it's going to stretch or compress. It's going to stretch. Okay, vertical stretch. Now, since x minus 1 squared, it's going to move either left or right, right? So this time it's going to move right. It's a right shift of 1 unit. And since we have a positive 4 at the end, it's moving up 4. Shifting up 4. Okay, the vertex here is 0, 0 for our original function. So at y equals x squared, at this function right here, the vertex is 0, 0, isn't it? Just like we did, that's our parent function. We did that on the last page. The vertex is 0, 0. What's the vertex being translated to in this new function right here? Well, the vertex is, it's going to be positive 1, positive 4. Whatever your right shift, if it's a right shift of 1, it's a positive 1. And then if it's an up shift of 4, it's a positive 4. So positive 1, positive 4 is your vertex, is your new vertex. Axis of symmetry, remember axis of symmetry is x equals whatever this number is. So x equals 1. Does it open up or open down? Okay, if A is positive, it opens up. It's going to look like this. If A is positive. If A is negative, it's going to look like this. You know what? I should do a positive A and a negative A. Okay. Now, so which one is this? Is the A positive here or is it negative here? It's a positive 3, isn't it? So it's going to open up since A is positive. And last question, is the vertex a maximum or a minimum? It's going to be a minimum since A is positive. Okay, so because A is positive, it's going to open up, right? It's going to look like this graph. It's going to look like this. So if it's going to look like that, we have a minimum point. Okay, it's kind of a lot to take in. We're going to try the next couple, and then I want you to try one. So we're going from y equals x squared. We're being transformed from this parent function to this new function. Okay, y equals 1/5 times the quantity of x plus 2 squared minus 6. Okay, so let's look at the A first. Since A is 1/5, is that a vertical stretch or a vertical compression? It's a vertical compression because A is less than 1, right? 1/5 is in between 0 and 1, isn't it? It's less than 1. So it's a compression. Since it's x plus 2 squared, remember, look back at your notes if you forget, but x plus 2 squared means we're shifting left 2 units. And since it's a negative 6, we're going to shift down 6 units. Okay. Now, the vertex started at 0, 0 for our parent function. It always is 0, 0 from our parent function. What happened from our parent function to this function right here? Well, we always look at these two pieces. The left shift of 2, so that means a negative 2, right? And it also went down 6, so a negative 6. So our vertex should be negative 2, negative 6. Negative 2, negative 6. Axis of symmetry, remember axis of symmetry is always x equals, and it's x equals this guy. So whatever that number is, it's x equals negative 2. Does it open up or down? It opens, well, is A positive or negative? A is a positive, right? So if it's positive, it opens up. And then also, is our vertex a maximum or a minimum? Well, since A is positive, it's a minimum because A is positive, and this is how our graph looks. All right, let's try another one. So we're going from y equals x squared, our parent function. How is this function transformed from the parent function? Okay, so it's a vertical stretch, right? How do we know it's a vertical stretch? Because of this 2. Remember, we do not look at that negative part of the 2. That negative tells us something else. This 2 is by itself. That 2 means it's a vertical stretch. So I'm going to actually write that because I didn't write that in, and I think that's important. Vertical stretch since A equals 2, right? Doesn't matter if it's negative. The negative comes in next. Watch this. It's an x-axis reflection since, not Cena, since A is negative. Okay, that's really important. All right. It's a left shift of 1 because of this guy, because of the x plus 1 squared. And it's a downshift of 1 because of this guy, because of that minus 1 at the end. Vertex went from 0, 0 for our parent function. It transformed into, okay, well, left shift of 1 means negative 1 for our x. Downshift of 1 means negative 1 for our y, so it should be negative 1 for our vertex. It's our new vertex after the function has been transformed. Does it open up or, oh, getting ahead of myself. Axis of symmetry. Axis of symmetry is always x equals whatever this number is, whatever the x is for our vertex. So x equals negative 1. Does it open up or down? Well, A is negative, so it opens down. And vertex is a max or a min. This time it's a maximum since A is negative. Okay, kind of makes sense. So this one, I think, yeah. Okay, this one I have you try. So try following the same things. And then raise your hand when you're finished. I want you to show me. Show me your answer. Okay. I want to see all of whatever we did for the 3 examples. I want you to see those exact same things, okay? Explain why. All right. So formats and converting formats. So we're used to the vertex form, but there are 2 formats in which quadratics are written. One is standard form, and one is vertex form. Now, standard form is written like this: ax squared plus bx plus c. Vertex form is written like this: a times x minus h squared plus k. We are so used to this form by now. We rock at that form, right? That's the form we've been working on this whole time. But, of course, now we're going to introduce something new. So, standard form. So, to determine the vertex and axis of symmetry of a function in standard form. So, how do we determine it in this form? Well, we just did it on the last couple pages. We've been working on that, right? The vertex is always h comma k, okay? And the axis of symmetry is x equals whatever that x value is for the vertex, right? But for a function in standard form, this is what we have to do. The first thing is we have to identify a, b, and c. Okay, then we have to use the vertex formula. This is the vertex formula right here. Then x is the value of the vertex. Okay, this is all going to make sense. We're going to apply this to an example. The third thing is we're going to substitute the x. So whatever you get here, we're going to substitute that back into the equation to find the y value of the vertex. And then you're going to write it in vertex form. So let's look at an example. Find the vertex axis of symmetry and convert to vertex form. So we have 3 jobs here to do. Now let's look at these 4 steps. Okay, let's go in those 4 steps. So here's the example. Now notice this. Everyone look at the screen. This is written in this form, isn't it? Okay, can you see how that is written? There's an ax squared plus bx plus c, right? So all of that should be written. You should notice that that is in that form. Now let's identify. Let's do the first step. The first step tells us identify a, b, and c. So a equals 3, b equals 18, c equals -1. Okay, not too bad. That's the first step. The second step, it says to use the vertex formula. This is the vertex formula. So we're going to plug in what we have for b and what we have for a. Okay. Notice it says negative b. So negative what? Negative 18 over 2a. And a is 3. A right there, that's 3, right? So we're just plugging in b and a. We're keeping that 2 there. Negative b over 2a. And x equals negative 18 over 6. Negative 18 divided by 6 is negative 3. So that's our next step. So use the vertex formula to find x. So x here, right here, this negative 3, that's the value of the vertex. Okay, so now number 3 tells us to substitute our 3 in for x in our equation to find y. So we're substituting that negative 3 in. Do you see how for this x right here we have a negative 3? For this x right here we have a negative 3, and we're keeping all of the other numbers the same. Okay, so don't forget we have to do negative 3 squared first. Do you see this piece right here? That negative 3 squared, we have to do that first. Do not multiply 3 times negative 3. Okay, everyone look at the screen. Don't multiply these first and then square it. You're going to get the wrong answer. You have to do this piece first. So remember, because of PEMDAS, we have to do exponents in parentheses first before we do multiplication. So what's negative 3 times negative 3? It's 9. So now we're going to replace just that piece with 9. Okay, do you see how we got from this step to this step? Because that's really important. So now we have 3 times 9, which is 27. 18 times negative 3 is negative 54 minus 1. Y equals negative 28 when we combined all of those. Okay, so now the fourth step is to write it in vertex form. So we know the vertex is negative 3, 28. We got negative 3 and then 28 here. Negative 28, I'm sorry. Axis of symmetry. Axis of symmetry is x equals whatever your x value is. So x equals negative 3. And the vertex form. So we're writing it in vertex form, which is up here. A times x minus h squared plus k. All right. So y equals, our a is, we identified it at the very beginning. Look at step 1. Step 1 says a is 3. We're going to keep x minus, and see how we have an x minus negative 3? Oops. See how we have an x minus negative 3? Right here. Okay. So we have x minus, and we're plugging in negative 3 for our vertex. You see how this negative 3, that's where this is coming in. Okay. And then plus k. And our k is negative 28. Our y is negative 28 here. Okay. So look at our vertex. So technically then, okay, so now we could write this piece, x plus 3, right? Minus a negative is plus. This piece, that negative 28, comes from here. Okay? This 3 comes from here. And this 3 comes from our A. Got it? So let's try another one. We just have one more example. So the first step here, it's y equals negative x squared plus 10x plus 2. The first step is to identify A, B, and C. A is negative 1. Remember, if there's no number in front of the x squared, it's a negative 1 or a 1, right? B is 10. And C is 2. Okay? Now, let's look at the second step. The second step says to use vertex form. What's vertex form? That's vertex form. That's the second step. Okay? So, now we're going to plug in negative b over 2a. We're going to plug in b. What's b? B we got is 10. And a is negative 1. So we're going to plug in negative 10. So negative b. So negative, and then b was 10. Over 2 times a, and a is negative 1. So negative 10 over negative 2 is 5. So our x equals 5. Okay. The third step says to substitute x into the equation to find the y value of the vertex. This is our x value of the vertex. We need to find the y value of the vertex. So let's plug it into our equation. Now this equation is the same here. I just wrote it down so I can plug it in. Don't forget, see that negative right here? Notice how I'm carrying it down and then I'm plugging this number in. Now I'm going to plug in 5. Okay, that negative is part of the equation. It came from part of the equation, so be really careful there. So I'm plugging in 5 just to my x. That negative came part of the equation. Plus 10 times 5 plus 2. So I'm plugging in 5 wherever I see x. Okay. All right. Y equals negative. So that negative stays here still. All I'm doing is squaring. 5 squared, right? Remember, we do not distribute that negative in. We square it first because of PEMDAS. So 5 squared is 25 plus 50 plus 2. So that negative came from the equation. We have y equals negative 25 plus 50 plus 2. So y equals 27. So our vertex is 5, 27. This, comma, this, right? Our x, comma, y. Axis of symmetry is x equals whatever this guy is. X equals 5. Vertex form. This is what we're trying to plug it into. This is our vertex form, right? This right here, that's our vertex form. So, y equals, what's our a? Our a is negative 1. Times x minus 5. Where did I get the 5? From our vertex. That's what I just got right there. X minus, so our h is 5. Squared plus 27. K is 27. That's just that point of the vertex. Okay? And that's it.